This is R.D. Sharma solution, class 12th. Chapter 9 continuity exercise is 9.1. Here, the point is 1. That is, you have to check the continuity or discontinuity at x equals 1. And the left hand side and right hand side, that is the domain, is also given. So how do we do this? We will try to find out the left hand limit and right hand limit and see whether they are equal or not. So the point is 1, that is 1 and below, 1 and above. Since x is greater than 1, x is less than 1 will use 1 plus x square. Greater than 1 will use 2 minus x. And we'll use 1 minus h and 1 plus h because we have to check at 1. So left hand limit x will be equal to 1 minus h. So we are going on the backward side. So of 1, so we'll use 1 plus x square. Since we are moving in front now, x greater than 1, so we'll use 2 minus x. And what did I tell you? The points, or you can say the limit, for limit we'll use x as 1 minus h, in this case left hand limit, and RHL will use 1 plus h. Just put it here. 1 plus, in place of x, replace it by 1 minus h whole square. In place of x here, just replace it by 1 plus h. So what will it be? 1 plus a square plus b square minus 2ab. Here 2 minus 1 minus h. So this becomes 2 plus h squared minus 2h. And here we have 2 minus 1 is 1, 1 minus h. Okay. Let us apply the limit now, h tends to 0. So this, how you have to write is on the left side what I have shown you. This is what is the way you have to write. Now coming back to h equals 0, the left hand side, left LHL will be 2. Here it will be 1. So, what 2 and 1 are not equal. That means the LHL and RHL are not equal. That means at x equals 1, this is discontinuous. Now we have to check the continuity at x equals 0. Now three different fx's are given. That is, graphically if I can show you, x is 0 here. Now the value of the function at x equals 0 is 3 by 2, which is already given in the question. If we go backward, that is below 0, that is, we are going to use 0 minus h in this case for limit. And the function value is sine 3x divided by tan 2x. On the right hand side, when we move forward, of course, we are going to use 0 plus h because 0 is the point we have to check. And the function which we are going to use for the 0 plus h, because x equals to 0 is already given 3 by 2. Left is what I showed you. And right hand side, it will be log 1 plus 3x divided by e raised to x minus 1. Okay. So just we have to check at 0 minus h whether this left one is 3 by 2. At 0 plus h whether the right one is 3 by 2. Let us check it. So I'll just write this LHL. This is RHL. Left hand limit. This is, let us apply directly here, x equals 0 minus h, that is minus h we are going to use. Here x equals 0 plus h, so we are going to use h here. So sine 3 is 0 minus h divided by tan twice of 0 minus h. Here what we are going to use? Log 1 plus 3 into 0 plus h, and in the denominator we will use e raised twice of 0 plus h and minus 1. So this is sine, see, I am showing you this one, sine 0 minus h is minus h only. So sine minus 3h it will be. Now we know that sine negative theta is minus sine theta. So minus sine 3h it will be. In the denominator as well, you will get tan minus 2h. What is this? Negative comes outside, so it will be tan 2h. So minus tan 2h it will be. That is, tan negative theta is equal to minus tan theta. So minus tan 2h. Negative, negative you can cancel. On the right hand side, it is 0 plus h. Of course, h we are going to use. Log 1 plus 3h divided by e raised to h minus 1. Now there are 4 different you can say limit which we need to use, because e raised something minus 1 divided by that something, if we take limit that thing equals 0, that is e raised x minus 1 by x divided by limit that x tends to 0 is 1. So we'll try that there should be 2h in the denominator. Similarly, log 1 plus theta by theta, or log 1 plus k by k, theta tends to 0 or k tends to 0, that means it is going to be 1. That we already know by previous discussions. Here also, sin theta by theta limit is 1, tan theta by theta limit 1. So tan theta by theta limit theta tends to 0 is equal to 1, and this sin theta divided by theta is also equal to 1. So you can cancel this negative sign. So sin 3h by 3h we are dividing, multiplying by 3h. In tan 2h also we are dividing it by 2h and multiplying it by 2h. On the right hand side it is log 1 plus 3h, so we have to divide it by 3h and we'll multiply it by 3h. Denominator e raised to h minus 1 and we'll divide it by 2h. Now just apply a limit, because so we'll just apply limit to all of these functions, and you know what will be the value, all will be 1. I am applying limit h tends to 0 to each and every 4 options which have. This is 1, this is 1, h you can cancel 3 by 2. Here also this is 1, this whole is 1, this whole is 1, h you can cancel 3 by 2. Okay, left hand limit, right hand limit 3 by 2. What is the value of the function at x equals 0? It is already given in the question, which is given as 3 by 2. So the left hand limit and the right hand limit and the value of the function at x equals 0 is 3 by 2. So the function is continuous at x equals 0. Okay. Find the value of a for which the function f defined by. Now we have to find out the continuity or discontinuity at x equals 0. So x equals 0, what does it mean? See, we have to check at x equals 0. If you go on the opposite side, that is on the backward side, it is a sine pi by 2 x plus 1. On the right hand side or on the forward side, it will be 10x minus sine x divided by x cube. So what we'll do here is, on the left hand limit side we'll put 0 minus h, because we have to check at 0. On the right hand side we'll check at 0 plus h. Okay. Let us see what it comes to be. That is, we have to apply 0 minus h and 0 plus h. And we will equate them so that we can find out the value of a, because we have to find out when this function will be continuous at x equals 0. So LHL, RHL, and as I said, we will equate them. This is, left hand limit is what? See, 0 minus h will be replaced in place of x. Here also x equals 0 plus h. So that is negative h only, and this is positive h, because it is 0. We have to check at 0. So it will be a sine pi by 2 and x will be minus h plus 1. Here we have tan, in place of this x I am putting h, tan h minus sin h divided by x cube. Now keep an eye on x cube. We'll do that in a short while. So here I'll just apply a limit here only, because it is sin pi by 2 minus h plus 1. There is only one h. So if you apply a limit, minus h will be 0. It will simply sin pi by 2. So when I apply the limit here, it will be sin pi by 2. And sin pi by 2, sin 90 degrees what? When we apply limit h tends to 0, sin 90 is 1. So on the left hand side limit we have a only. Okay. So now coming to right hand side. Tan h minus sin h divided by x cube. So just keep an eye on x cube, because we are going to replace it by h cube. X has to be replaced by h. So tan will be sin by cos minus sin h. I am taking sin h outside. It will be h cube. I will use it later. So sin h, it will be 1 minus cos h divided by cos h, and 1 minus cos h is 2 sin square h by 2. Okay, and this cos h in the denominator, the sin h by cos h, you know, already know, it is tan h, and tan h by h is 1 if you apply the limit h tends to 0. So what we'll do here is, this 2 I am taking outside. Sin square h by 2 is simply sin h by 2 square. So sin h by 2 whole square. So we need to have h by 2 whole square in the denominator, and we have to have h by 2 in the numerator. That's what we are going to do here. So h square by 4 and h square by 4 here. So 2 we have taken outside. Now let us apply limit here and limit on tan h also. Because tan h by h is simply what? It's 1. We know sin theta by theta is 1, so you can just replace it, sin h by 2 and h by 2 whole square. Now you have 2 tan h, and this is h square by 4. So as I said, we need to have one more h. So I am taking 4 here, h, and multiply one more h with h square. That is tan h by h we want, because we will apply the limit, and tan h by h is, we have already seen in the previous question, is going to be 1. And since h square is there, we will multiply it by h, because h we have already introduced in the denominator of tan h. So tan h by h is 1. I am applying the limit here, so just I am replacing it by 1, because we know that tan h by h, limit h tends to 0 is 1. Now we have a h cube here, h square into h. But since, if you remember, there is x cube already there, and x cube has to be replaced by what? X cube has to be replaced by h cube. And since we have h square into h, which is h cube, and this x cube is h cube. So now we have, I am introducing this, I have not used it while doing this. I just told you that I am going to use it later. So h cube it is. So h square into h is h cube. You can just cancel these two. So you have 2 by 2, 2 by 4, that is 1 by 2. So left hand side it is a, right hand side it is half. So you can just equate a with half, and you can say LHL equals RHL. That means a has to be equal to what? A has to be equal to half. So that is the final value. In order for this function to be continuous at x equals 0, a has to be equal to half. Okay? Examine the continuity of the function at x equals 0. So we'll just do it quickly, because x equals 0, and left, right will go left for left hand limit. So we'll use 0 minus h, because we have to check at 0. On the right hand side, we'll apply 0 plus h, because we have to check at 0 only. On the left hand side, when x is less than or equal to 0, you will use x plus 1, 3x minus 2. On the right hand side, we are going to use x plus 1. So 3x minus h, replace x by 0 minus h. That is minus h only, and x equals 0 plus h on the right hand limit. So 3 into, in place of x, it is minus h, so minus 3h minus 2. Here x plus 1, so we have h plus 1. Now apply h equal to 0 as a limit in both the LHL and RHL. So what do you get? You get negative 2 here. On the right hand side, you get a 1. So what do you see? Negative 2 and 1, they are not equal. Negative 2 and 1 are not equal. That means the function is discontinuous at x equals to 0. Okay. Now coming to the graph, what are you going to make the graph? See, these are simple lines. Y equals 3x minus 2. Y equals x plus 1. So you have to make a line. And I hope you will be able to make the line. Because y equals 3x minus 2, just put the value of x as 0, negative 1, 1. In place of y equals x plus 1, just replace it by x as 0, minus 1, 1. Find out the value of y and just plot it. So these are straight lines. And once you put the straight lines, you will surely see that this is discontinuous. I'll show you this in the next question, what exactly I mean. Discuss the continuity of the function fx at the point x equals 0, where fx is this. So if x is 0, it is 1. That is y equal 1. x is greater than 0, it is x. At x less than 0, it is negative x. So I hope you got the idea. This is just a modulus of x graph that will start from 1, not from 0. Okay, I'll just show you the graph. This is how you're going to make the graph, because in the previous question you have to sketch the graph. This is y equals x, y equals minus x. That is the graph. But it will start at 1. Now coming back to our continuity and discontinuity, we have to check for left hand limit and right hand limit. So LHL, RHL, just replace x by 0 minus h in the LHL, 0 plus h in the RHL. So minus x and plus x. In minus x, this x we have to replace by 0 minus h, it is actually equal to minus h only. And on the right hand side, it is 0 plus h, it is equal to h only. H is very small number which is equal to 0, which is not equal, it is not 0, but it is actually nearer to 0, very near to 0. So minus minus become plus, and h here also, when we put x as h, now apply the limit, it is going to be 0 here. And this also apply the limit, it is going to be 0. Okay, 0, 0. But LHL, RHL is okay, they are equal, but don't think that this is continuous. Why? Because you'll just see that the value of the function at x equals 0 is 1. f0 is 1. Okay? So this is not matching. If it is not matching, what does it mean? It is discontinuous at x equals 0. From graph also, you see, you have to, there is a sharp turn, and that sharp turn is discontinuity. Now same thing we have to do, but at x equals half. So we have to discuss the continuity of the function f(x) at x equals half. So this is the point half. On the front side, on the backward side. So if we are going in the front, that is half to 1, we will use 1 minus x. On the back side, we are going to use x. From half, front and back. So LHL will be what? RHL will be what? In left, we are going to use x as half minus h. On right, we are going to use x as half plus h. Okay. Now function what we are going to use? X is half minus h. It is directly x only, so half minus h. Here 1 minus, in place of x replace half plus h. 1 minus half is half only, and because half negative h. Half minus h. Now half minus h, apply the limit h tends to 0, it will be half and half on both the sides. So LHL, RHL both half. Same thing we are going to apply it here, h is 0. So half and half. Now you see the value of the function at x equals to 1 by 2 is also half. It is also half. So LHL, RHL and the value of the function at half is all half. So the function is continuous at x equal to 1 by 2. Okay, this we are going to see at the next discussion, or let us do it here only. So we'll use it at x equals 0. We'll do it quickly. So on the left hand side it is 2x minus 1, and here we have 2x plus 1. On this 0 minus h will apply. On this we'll apply 0 plus h. 0 minus h is negative h only. 0 plus h is h only. And just apply it here, LHL, RHL. You know the drill now. So this is twice of x is 0 minus h. Of course, we have to write that, because I'm just giving you the logic. The actual scenario you have to write by yourself. So 0 minus h, so minus h, 2 minus h, minus 1. Here we have 2, 0 plus h, plus 1. So you have minus 2, minus 2h minus 1, minus, and here 2h plus 1. So h just put as 0, limit h tends to 0. It is going to be one side it is negative 1, one side it is positive 1. And since left hand side, right hand side both are not equal, the function is discontinuous at x equals to 0. Okay? They are not matching. Discontinuous at x equals to 0. This is the final thing which we need to see. Okay, this we are going to see in the next discussion. Till then, thank you so much. Take care of yourself.